Hi, my name is Noel Gorelick. I'm one of the founders of Earth Engine. Today I'm going to talk about Earth Engine debugging, or how to make your scripts work. Who's seen this presentation before? Great. So the jokes will be new. OK, so we're going to talk about 4 things. Basic debugging, things that you can do to avoid errors in the first place. Common errors you're going to hit and what to do about them. Some of our performance analysis tools, or tool, really. And then a little bit about getting help. So basic debugging. I'm going to assume you're using the code editor. If you're using Python, you've got other problems already. But in the code editor, there's some things that it does for you just straight off to help you do your debugging. Oh, look, a laser. So if you have invalid JavaScript syntax in the code editor, it will tell you. There's little red boxes that say you've got a problem. Often, these little red boxes are a little misleading because it's super hard to figure out what you really meant when your JavaScript is broken. So sometimes it says missing trailing brace or something, and you're like, I don't know what that is. But really, it's just an indicator that something is probably wrong somewhere around here. You should go look carefully at the lines right here and right above it. There's things that will happen on the client side where we can catch an error very early before it's even made it to the Earth Engine system. And that's often things like typos or missing variable names or something like that. And then there's a bunch of server errors that are much harder to debug because they're already on the server. But we try to give you what we can in terms of a meaningful error message. Often we fail, but we try. So mostly I'm going to talk about server stuff and things you can do about it. Unfortunately, our debugging tools are pretty 1970s. Most engineers actually do their debugging with print. So for us, this is fine. But it's not much of a tool. You have to actually kind of know what to print. But you can print things out, and we'll tell you what it looks like, and that will help a lot. As I'm building a script or I'm debugging it, I add almost every single line to the map, or just a few. I only go a few lines before I add something to the map and look at it. And especially if I'm looking at array-based images, I can't ever do the array-based image analysis in my head. I just stick it on the map and look at what my array looks like. And if it's right, great. If it's not, I go figure out what's going on. And so that means I'm using the inspector to look at those objects all the time. I'll talk a lot about how you debug mapped functions. But the tools for that are filtering, limiting, and getting an element out of the collection. You'll see that in just a second. And then there's one more function I want to talk about that the client library provides, and that's aside. It's a special function that you can stick in the middle of your script and have it call another function on the thing it's on. So every single Earth Engine object has this function on it. And so if you've got some gnarly object, often you'll want to print that. But maybe it's in the middle of a bunch of calls that are all strung together. And in order to get to the middle of it, you'll have to make a new variable and break it apart. That's often disruptive to your script. So when I'm debugging your script, I am usually just shoving some aside prints in the middle because it returns the same object that went in. So image.aside returns that image, but called print on it along the way. Okay? So the Earth Engine client library is built for method chaining. This is another method you can just chain in and not have to completely rip apart your script to be able to stick a print in the middle of it. That used to be called the Noel function. Like that's for me to help debug your code. OK, so a quick example. Often, you'll have a function. You'll be trying to map it over some collection. In this case, we're doing some kind of reduced region, getting the value out of the reduced region, like an NDVI value, and then doing some kind of band math with that value. It is not uncommon that you'll run this kind of thing, and you'll get a message that looks like this. As it was processing ID number 16434, something happened, and the add stopped working. Is there an add in there anymore? There's not even an add in there. This would be where. I simplified this earlier today. So image.where parameter left is required. The problem with mapped functions is they all happen on the server, and they're not a thing that you can debug, right? You can't print in the middle of them. So the recommended methodology here is filter down your collection to get to just the problematic element. It told you what the element name is, so filter down to just that, and make sure that that is actually the problem. So just map over that collection of one element and see that you get the same error. If you do, great. Because now what you can do is you can extract that element and call your function on that element directly. And that will let you shove an aside into your function and print it, and you can now actually see what's wrong with that object. In this particular case, what probably happened is the reduced region had no pixels inside of it. So it produced a null value. When you get it, there's nothing there. And then when you try to use that null value in an add or a where, it's going to fail. But when you print that result of the reduced region, you'll see, oh, I've got an object with nothing in it. That's my problem. And you can then try to solve it. So filter down to 1, pull that 1 off, and run it through the function you were trying to use. OK? All right, so common errors that you'll hit. There are things that we call early errors, lots of errors that can occur inside of mapped functions, a bunch of things you shouldn't do. I'll lay out some of those. A little bit about scaling issues. And then in the past 45 minutes, it occurred to me that I do office hours out here all the time. And people come up and say, here's my 3,000-line script. It doesn't work. Please help. I do that. That is my life. That's like what I do. So I have essentially an internal checklist of, I can go through a 3,000-line script in about 10 minutes and say, yep, here's your problem, which makes me look like a superhero. But really what's happened is I know where all the rough spots are. And there's whole blocks of code that's like, OK, none of that can go wrong. The problem is this line at 2,700. So I tried to write down really quick my checklist, because it's never been written down, so that when you have a problem, you can just go through the checklist and, or better yet, avoid those problems altogether. So that's going to be really rough, but we're going to go through it, and it'll be recorded, and hopefully it'll help. OK, so here's an example of some early errors. If you've got a line of code that looks like this, you've got some problems. It's going to error out a couple different ways. Does anybody see what's wrong with this line of code? The division is not going to work, correct? What else? And the multiplications will work. Those are just constants, so you can do that. The result value isn't captured anywhere. So you've set a value, but it returned an object, and you discarded that object, so the set didn't work. So you need to do something to capture your results. And you can't use this operator here, because there should be parentheses here. You can't use a plus on this computed object, because this computed object only exists on the server. And the plus happens in your browser as soon as you run the script. So you're actually trying to add some proxy object that doesn't exist to some constant. And what JavaScript helpfully does when it's trying to add objects is it will convert it into a string, which will be some really long, ugly piece of JSON that means what you meant to do. And then it's just going to shove this other number on the end of it. And that's not going to run. So you can't use these kind of operators on computed objects. You can use it on these. Those are just literals. Those actually, that math will work. But the other one won't. So fixing this, you need to capture the result into some variable. You need to use divide instead of slash. But the divide is not going to work if you just stick it on the result of get. A whole bunch of this talk is about the whys, not just the whats, but the whys. Get returns a property out of some object or an element in a list. Those properties or that list can contain anything. It can contain strings, numbers, images, entire collections, collections of collections. It can be anything. And the client library can't know what that's going to be until, well, it just can't know. The server knows once it's got it, but the client can't know. So you can't call functions that are on those things like divide unless you've told us what it is, and then we provide those functions. So in this case, you either need to cast the result of getting system time start into a number, so that then divide is a thing, or there's a couple shortcuts for numbers, strings, and what's the other type in JavaScript? Number, strings, there's another one, whatever. Get number, get string. So once you've said get the number, OK, now we know that the thing that we're going to be, you think the thing we're getting out is going to be called a number. That may still fail if it's not really a number, but then we know that, or the client library knows that that object should have a divide function on it, and you can then use that divide function. Okay? So this is all about casting, making sure the things are the right type so you can get to those elements. And then anytime you do math with computed objects, you have to use server-side functions. You can't use the infix notation. Make sense? You with me? OK, so this will go pretty good. There's a lot of stuff that is a dichotomy of client-side and server-side. And if you don't understand that you run stuff in your browser and you generate a description, and the description goes off to the server, and the server then runs stuff, it's very easy to make mistakes. The working with mapped functions is one of those places, because the entire thing in the mapped function, how do I say this? When you've got a function in your JavaScript and you map with it, what we do is we actually run that function once with a proxy object, like an EE number proxy object. And as that number bounces through your function and does its thing, it collects computational descriptions. You're doing things to a proxy object. At the end of the script, we say, OK, proxy object, what happened to you? You know, the object that gets returned, we say, what were all the functions that got called on you? And that's what we package up and send off to the servers for applying your mapped function to things. The important part of that is the function is run once on the client, but no more. When it gets to the server, it's going to be run thousands and thousands of times, but once on the client. What that means is that there's some things that the function has to do. So common problems with the function, it has to return something. Because we're expecting that proxy object at the end that we're going to query and say, what happened to you? If it doesn't return anything, the function does nothing. Okay? If you're mapping over images or features, the thing that has to be returned is either an image or a feature. So you can't map over a bunch of images and return their dates, because that would be a collection of dates, and those don't exist. Collections are either images or features. So you can either convert your images to a list and get back a list of dates, or you'd return a feature containing a date. Similarly, the getInfo can't work inside a mapped function because the thing that you're working with doesn't exist. It's some proxy object. It has no data. It has no metadata. It's going to have it when it gets to the server. But if you getInfo it in the middle of your function, there's just nothing to return. So you can't use getInfos or prints inside of mapped functions. A place that people frequently get confused is trying to do some kind of control flow inside of a function. So if you use an if in the function, it will work, but probably not the way you expected. Again, we run that function once. We run it on some proxy object, which means regardless of what's in this if-else statement, only one half of it ever happens, ever. Right? We bounce an object through the function. The if happens based on something one time. And so either the true part or the false part is what gets captured into the description. And that's all that ever happens. The if doesn't run multiple times. And even worse, if I, in this case, is a computed object, computed objects always return true. So, or in this case, it'd be false. So computed object equals 0. That is always false. It doesn't matter what I will actually contain. Some dictionary never equals 0. That's what this is. So this is always false. It will always return 2. Nothing can ever return 1. So what that means is don't use ifs. The one place where it's OK is if you have flags at the top of your script. It's like, today I want my script to use algorithm number 8 with Landsat 5. Okay, you set those things at the top. Using those ifs down in here are fine, because every time you use that function, it's going to always be using Landsat 5. So flag testing is fine, but computed objects, not OK. All right? And then mapped aggregations aren't actually an error. They're just a problem where they're a place where you can have a problem. When a mapped function makes it to the server, it gets run 20 times in parallel, give or take. When you run something like a reduced region, it starts up something like 20 workers to try to answer your reduced region call. You can't have 20 mappings running 20 reduced regions at the same time. They'll get throttled. It used to be an error. You'd get a too many aggregations problem. We at least fixed the error, but now it gets throttled down. So just be aware that if you're doing some kind of reduction inside your map, it can be a little slow because there's a certain amount of parallelism you get, and we won't let you explosively consume machines. Does that make sense? I see some nods. I see some not nods. Yeah, OK. We'll keep going. Definitely ask questions along the way if something doesn't make sense. Things you shouldn't do with Earth Engine. You should not use for loops or get infos. There is one place in the entire system where you still need to use a get info, and that's if you're trying to export an image collection. You kind of have to use a get info to make that work. But any other place, you shouldn't use get info except for debugging purposes. Never make control flows based on the output of a get info or something like that. The reason is you can very easily crash your browser. So your client-side for loop working on a million-element collection, that's going to crash your browser because you pull your million elements over to the browser, and your browser is just going to sit there chewing away on that until it fails. So if you're using for loops or get infos, you are at risk for crashing your browser. Don't do that. This is a fun story. I teach this debugging session frequently. Before I had this in there, I had someone come to one of my debugging sessions and say, well, I'm an advanced GIS user. I wanted to run a reduced region using EPSG 4326, and I know that that is at a scale of 1 degree per pixel. And so I really wanted 30 meter pixels, and so I know that 0.00026 means 30 meters per pixel in EPSG 4326. Do you know what the problem here is? Scale always means meters in Earth Engine. It should be called scale in meters. It always, the word scale always means meters. So what this person asked for is 26 micron pixels, and it didn't work. And so when it doesn't work, it says too many pixels, and it returns an error message saying, you asked for a whole bunch of pixels. That's more than the 100 million we allow. Problem. And when I teach 101, I say, never copy and paste that number it gives you into your script, because 1, it won't work, because there's always some fractional pixel, but 2, it might be 92 exabytes. If you're using 27 micron pixels and you're trying to do the United States, that is it's a very, very large number. This will never, ever, ever work. So if you are copying and pasting some ginormous value somewhere, think about it. Stop. Especially in the case of reduced region, the max pixels argument in reduced region is a thing we call the blade guard. When you buy a table saw in the US, there's this piece of plastic that sits on top of the blade, and that's designed to keep you from cutting off your fingers. And every single person in the US immediately unscrews that and throws it away. OK, great. That was a decision you made, but the saw was sold with a blade guard on it. When you run a reduced region, somebody has to pay for the computation you are running. If you're an academic or research user, I pay for it. If you're a commercial user, you pay for it. And so this number is to make sure that you're not accidentally starting a 92 exabyte job that's going to take weeks and weeks and weeks to finish. I want you to think about what's happening when you run a reduced region. And if you get the error that says too many pixels, you fix it with a max pixels setting. But think about this number. 1 e to the 9th, that's safe, no problem. 1 e to the 10th, that's OK. Think about it a little bit. 1 e to the 11th, that's pretty costly. 1 e to the 12th, that's not going to finish. 1 e to the 13th, that's ridiculous. 1 e to the 15th, heat death of the universe. there's 3, 6, 9, 12, 15, 18, 19 digits on that. Yeah, so just not going to work. But the user actually asked, why didn't my script work? And so I got to tell them. OK, so think about max pixels when you use it. Never, ever, ever convert to list unless you need to. You might think you need to. Try hard to not need to do it. Because when you take a collection and you convert it to a list, we immediately go get every element in that collection and materialize them in memory and make a list out of it, which breaks all of the streaming semantics built into Earth Engine, which is why you can process millions and millions of images, because we stream through them. If you convert it to a list, we can no longer stream through them. They all have to be contained in memory. And in this example, you could have just put the iterate over here, iterated on the collection directly, and not needed the list. So you made a big giant list of images, or whatever it was you were using up a ton of memory that you didn't need to use. Yeah. The question is, sometimes you need a for loop, and you're right on that edge of a place where you might need a for loop. You're not allowed to use computed strings to identify tables and images. So EE image collection or EE feature collection with a string, that string cannot be a computed string. And there's a long security reason why that's not allowed. But in those cases, if you want 20 tables, you're going to have a client-side list of 20 table names. And yes, looping over that list of 20 names to make 20 tables is acceptable. If that list is 20,000, it ain't going to work. So it's definitely a place. And I use for loops all the time. It's just a place where, if I'm doing I've got 10 bands in an image, and I'm trying to load all of them onto the map. That's a place where you need a for loop. So it's just a place to be aware you are stepping on the third rail on purpose. So be careful. OK, there's another question in the back.
What's the best way to get the last element of a collection?
There is a last function, but it goes through the entire collection. One of the things about Earth Engine is that collections are iterable. And the contract on iterables is that the only way to get through it is to call next until you get to the end. So you can use the last function, and it will call next for you a gazillion times and get you the last element. But a much better solution is usually sort on whatever element you think it is and then take a first.
Thanks.
They're about the same cost either way. Okay. All right, so onward. Different kinds of scaling issues. User memory limit exceeded is the one you're probably going to hit the most often. There's also things like computation timeout. It's uncommon you'll hit too many aggregations anymore, so I might have even removed that one. And then all kinds of internal server errors. So I forget what these next 4 slides look like. We'll see. We'll find out. Yeah, all right. So these are just some errors, and then I'm going to tell you how Earth Engine works so you understand what the error is. I could just tell you the answer, but that's not going to help you. It will get you around this problem, but it might not help you on the next one. So really common problem when you run something like reduce region or reduce regions is that it will say computation value is too large or computer value is too large. What this means is that you're running an aggregation, and aggregations always get stored in our cache. And the limit size, the cache limit size, the size limit on the cache is 100 megabytes. So any kind of reduction you do has to fit into 100 megabytes. That means you can't make a table bigger than 100 megabytes. So if you run reduce regions with 1 million elements, and each element is extracting values from 10 bands, you can pretty easily run up against the 100 megabyte limit. So when you see a computer value is too large on your tables, the answer is to break it into pieces. Run the first 10,000 elements and then the second 10,000 elements as 2 different tables, and then figure out how to put them together at the end. You can merge two 99 megabyte tables into what would be a 198 megabyte table, or 100 of them if you really wanted to. But as soon as you try to transform that table with any kind of reduction, the output still needs to fit in cache. So the output always has to be less than 100 megabytes. Same thing for classifiers. Maybe you make a big giant pile of training data that's actually bigger than 100 megabytes. You train a classifier 5 or 6 times so that it all fits into the classifier, but you might end up making a classifier that is bigger than 100 megabytes. That classifier also has to fit in the cache, so you'll have to chop down the size of the classifier, either by giving it less training data or using some of the tuning parameters on the classifier to decrease its total size. Okay? So computed value too large, whatever you tried to do didn't fit in our cache, you'll have to deal with making it smaller somehow. Yeah, so a real common problem, you'll end up with an error that says feature has a non-numeric value for some property. This is usually when you're sampling data and you're trying to stuff that data into a classifier. The classifier will say, partially filled vector, I don't know what to do. This almost always happens because some of the bands are masked, especially on like Landsat. So you're trying to get all the bands of all of the surface reflectance bands of Landsat. In the 2018 timeframe, there were 3 months when there was no thermal data collected. And so if you take the entire Landsat stack and you squish it and you try to sample it, it's very easy that the thermal bands are blank if you didn't do it right. And so you'll sample that, the thermal bands will be blank, and the classifier will say, problem, I don't know what to do. So non-numeric value means something went wrong in your sampling. Go check your values, print them out the way I showed you earlier, and you'll see, oh yeah, I've got 7 bands, but not the 8th one. Okay? Make sense? All right. Task timed out after some number of seconds. This one's tough. It just means that everything you've put together is too big. There are a number of different timeouts in the system. There is, and these are almost always, well, when you're using Earth Engine, we have what's called the interactive stack, which is what the code editor normally is returning results from. So a get info or putting something on the map, all those things happen on the interactive stack. When you run an export, that's a whole different system. That's called the batch stack. If you're doing things in the code editor, you get 4.5 minutes from clicking run until it times out. There's a little bit longer in some cases, because often we won't, if you have 1,000 prints, we'll only run like 20 at a time. And so that time it doesn't matter. But once the query starts and gets to the server, we kill it after 4.5 minutes. Because it's an interactive stack used by tens of thousands of users, we don't want you monopolizing that stack. So 4.5 minutes on the interactive stack. And really no other time limits there. On the batch stack, there's a lot of different time limits. There is a limit of 7,200 seconds per feature. So if you're making a feature collection by sampling a big image or doing a whole bunch of computation, we send those out in parallel, and each one is only allowed to run for 7,200 seconds. And that's generally not a problem. If it takes longer, that's what, 10 minutes, I think. If it takes longer than 10 minutes to compute a single feature, something's not right. The most common place this will occur is if you are running like a reduced regions. That whole operation needs to finish in 7,200 seconds. But if you run a mapped reduce region, you can run those, each one has to finish in 7,200 seconds. All right, does that make sense? If you use Earth Engine, this makes sense. If you don't use Earth Engine, this is probably Greek. But just be aware that pieces of your computation have to finish within a certain time limit. There's one I'm forgetting, somewhere between 7,200 and 10 days. But your total batch task is only allowed to take 10 days. After 10 days, we'll kill your batch task because it's clear it's not going to finish after that. And really, you're probably not going to get a whole 10 days. The servers get rebooted every week. And so you're really only going to get 7 days on the outside. And really, they get rebooted on like Thursday. So if you start your task on Monday or Tuesday, you're only going to get like 2 or 3 days. And then it'll get 7 days on the second try. We retry batch tasks 5 times because sometimes stuff just happens, right? We reboot the server, some other person at Google yanks the server out from under us. Sometimes you will run a task, it will run 5 times, it will give you no output. It'll just say, I don't remember what it says at this point. It's just, there's no message about how it failed. It just failed 5 times. What's really happened is your task has killed a machine 5 times. And the other people running on that machine at the same time lose their task as well. So occasionally, something will cause your task to fail that was totally beyond your control. And we'll retry it again. We'll retry it up to 5 times, and then we stop. But that means that you could, and each one's allowed to take 10 days, so it could, so each one is allowed to take 10 days? The total. I think each one is allowed to take 10 days. So your task could end up spinning for a long time and ultimately not get there. Question in the back.
Question, how long is the cache conserved?
Yeah, good question.
Because it happens that I make a nice script and I try on the way when I do it, and then I send it and they told me, yeah, it cannot work on my side. And then I try like a few hours later, it doesn't work on my side, not anymore neither.
Yeah, there's a bunch of different caches. The one you're probably talking about is this one, computed values too large cache. Generally, that's 24 hours, but really it's until someone kicks your task out of the system, your cache element out of the system. So it's a least recently used cache, and when someone's really doing something they shouldn't, they can end up shoving terabytes into that cache, and when we run out, we get rid of the old ones. So there is no fixed answer, but generally 24 hours is not a crazy amount. You shouldn't rely on it though. Yeah. It's only designed for, I ran a task, now I'm going to go use that, I'm going to run it again, for instance, or something like that. Okay? All right. There's lots more scaling issues, but what I want to talk about, and timeouts. A really common timeout, the reduced regions doesn't finish in time, go to a mapped reduced region. This takes much, much longer to run, but each one of these gets a full 10-minute timeout, whereas the other one, the whole thing has to finish in 10 minutes. Okay, so now the funky new slides. You come up to me with 3,000 lines of code. I'm able to slam through that code in about 10 minutes and probably find your error. And that's because I'm looking for very specific things that are likely to go bad. And so I'm going to walk through this and say something about each line. And in the future, you'll be like, oh, what did he say about resample? And there's a video, and so you can see what I said. But this is almost my entire list. I couldn't think of anything else. Mike and Nick, who also typically debug with me, couldn't really think of anything else. So we'll just walk our way through this, okay? So the price of admission for getting help with your script is you better not have a getinfo or a for loop in it. If you do, I'm going to stop looking and send it back, right? Don't use getinfo or for loops, partly because I don't want my browser to crash. I got a lot of stuff going on in my browser. I don't want it to crash. So if you've got a for loop or a getinfo, start over, fix it. Then I look for iterate. Iterate's a tricky thing. Instead of a for loop, you should probably be using iterate. Or better, you should definitely be using a map. If you can use a map instead of an iterate, always do that. Because iterate gets to the server and, well, all right, let's explain why you don't use for loops first. One of the problems with for loops, so maybe you want to compute 10 different band indices or something like that and you think I'll do that with a for loop. Every time that for loop runs, you are adding something to your computational description. And so you're adding 10 chunks. If you're doing the for loop 10 times, you're adding 10 chunks to your computational description. And depending on what you're doing in the for loop, those chunks might be really large. So if your entire script is one giant for loop and then 3,000 lines of code, you're adding that 3,000 lines of code equivalent 10 times to your script, right? And so sometimes that just won't make it to the server. There's a 512 megabyte limit or something. So assuming it made it to the server, that's still this big giant computation that's a problem. Or big giant computation description that's a problem. So don't use the for loops. If you have to do it, use iterate. But the problem with iterate is you have this one function that you're going to run 10 times, and it gets to the server, and iterate expands that one function up 10 times. And so we end up with the same sized giant mess on the server because the only reason to ever use iterate is because the next loop needs something from the previous loop. Really that means a finished computation from the previous loop. If you're just trying to accumulate things into a list, don't use iterate. If you're just trying to accumulate things into a collection, don't use iterate. You don't need the previous element. You're just appending to the previous element. If you're doing finite element analysis where you do a computation and then you do another computation on the result of that, and then you do another computation on the result of that, that's a place where you actually need to iterate. And the size that you can make here is kind of small. You probably can't do a 100,000 loop iterate because it's going to try to build a giant computational description on the server, and that's going to take up too much memory. So if you've got to iterate, that's certainly a place to start looking and say, how big is the thing that's inside of it? Will it fit? That's a common problem spot. If you are converting things to a list to do things to them, make sure there's a valid reason for that. But going from collection to list to do something back to collection is a big red flag. So don't convert to list if you don't have to. Often when you run out of memory, it's because you are using geometries that are quite complex. I actually had originally said my mental note for this line was Antarctica. And so I was then going to tell you what the problem with Antarctica is. It's one giant geometry. Any country's database that you use that has a boundary for Antarctica, it's probably like 50,000 or 100,000 points. That's a really big geometry. And anytime anything intersects that geometry, we have to reproject all 100,000 points into whatever output projection you're using. So when people say, my script has run out of memory, one of the first things I do is, OK, what tables are you using? How many points are in that table total? Not lines, but take out all the geometries, flatten them out, see how big they are. Oh, you're using 1.8 million geometry, coordinates in your geometries. That's your problem. Okay, so simplify them if you can. Don't include Antarctica ever if you can avoid it. Yeah, so be aware that complex geometries cost a lot in Earth Engine. Don't clip if you can avoid it. Often you'll have something that's kind of a complex geometry, 50,000 points, something like that. That's not unreasonable. But then every line of your script you will clip with that geometry. And so you're reusing that great big geometry every single output line. It's not helping. It's not doing anything extra. In fact, you can write your entire Earth Engine script never clipping anything, and only at the very end, when you export, do you actually specify an output geometry, and then you're only going to get those pixels. So if you can avoid it, and you usually can, don't bother clipping, and definitely don't clip over and over and over and over and over. Okay? That doesn't mean you should never use clipping, but be aware that it costs a lot of memory with complex geometries. If your script has reduced to vectors in it, that's often a problem. Reduced to vectors makes big giant geometries, especially because it traces each pixel. So if you've got a big circle and you're running reduced to vectors on it, every single pixel outline of that circle, every single piece of the outline of that circle is a pixel. Like we actually draw the geometry around the pixels. So you can easily make million-point geometries, 10 million-point geometries with reduced to vectors, which sometimes is a thing you need. But if you then try to use that in a reduced region, you didn't need to, because reduced to vectors will do a reduction. So that whatever reduced region you're about to do, you could have just done with the reduced to vectors. But B, it's a complex geometry, and it's probably not going to go very well. If you're using reproject or resample or reduced resolution, you probably shouldn't be. But occasionally, there's reasons that you actually need to do that. So just be aware that reproject can often cause you to consume way more memory than you think you're using. And if you use reduced resolution, you have to use reproject. And so this is just a memory failure trap in progress, right? It's going to cause issues, and especially resample. So resampling, reprojecting down to like 1 meter, and then trying to reduce resolution up to 1,000 meters, that cycle is just never going to work. And then Mike had me add joins. There are two ways to do the equivalent of a join in Earth Engine. One is to use the join system. The other is to use map and filter. So if you've got a bunch of polygons and you're trying to join them with a bunch of images, for instance, you can do a join and try to match them up. Or you can map over the polygons and filter the image collection down to each one of those polygons. Both have pluses and minuses. If you're using a join and it's not working very well, try the other one. If you're using a mapped filter operation and it's not working well, try a join. So it's really hard to explain why one works versus the other. But if you've got a join in your script, I then want to very carefully inspect what you're doing and see if it's a problem spot. All right. Collections. Often people will cloud mask the entire Landsat catalog and then just use 3 images. So definitely filter date and filter geometry before you do anything else. If you're using calendar range, sometimes you need to. You just want the images from January. Make sure you have done some kind of filter date in front of that, because calendar range doesn't use any indexes, whereas filter date and filter bounds are very fast and they use indexes. So if you just say, here's the entire Landsat collection, give me all the images from day of year 1, that's going to take a really long time and touch every single image. And then you're going to say, give me all the images from day of year 2, and that's going to take a really long time and touch every single image. So try to filter to an appropriate unit first, and then calendar range on top of that. If you're taking the geometry of a whole collection, occasionally there's reasons you should do that. But again, that puts you right back into, I've got a bunch of complex geometries, be careful. Anytime you use collection to bands or collection to array, that is immediately sucking up a big giant block of memory. So those are often places where there's a problem. Make sure that you need to include everything you're including. For instance, if you take Landsat.toBands, you probably didn't really want all the QA bands and all of the saturation bands and all those sort of things. So get rid of the ones you don't want before you do the conversion. If you're running out of memory during an aggregation, there's a lot of places you can use tile scale. So add an extra tile scale or add the tile scale parameter to try to make it use smaller and smaller tiles. Do people know what tile scale does? 1, 2. Okay. When we do something like a reduced region, everything happens in tiles. Tile scale causes us to use a smaller tile. So if you, by default, the tiles are 1K by 1K pixels, and so that's usually 1 meg per band. If you've got 20 bands, suddenly that's a 20 megabyte chunk of memory. It can suddenly become very too much. And tile scale will just cause us to use smaller tiles. And so it takes longer, but uses less memory. So it's a time-space trade-off for you. Anywhere, when you run out of memory, use the tile scale to bump it up. Typically, these go from 1 to 16, which really just means use a 16th, divide each dimension by 16. Most people use 1 or 16. Be aware that using 16 makes your output take 256 times longer. Okay, right? It's a square function. So you want that number to be as slow as possible and still get you to work. So think about that when you bump it up to 16 and then you get a timeout because it's using many, many more tiles. If you are reducing to get a mean and a standard deviation and a variance and maybe a linear fit all on the same data, combine all those things together. Then we can just make one pass through the data and not have to keep pulling more and more and more tiles in. So anytime you can, combine your reducers. If you're doing reduced neighborhood, make sure your neighborhood size is sane. Anything more than 1,000 pixels in a neighborhood is probably not going to work. That's a huge, for Landsat, that's 9 megabytes per band times 10 bands. That's 90 megabytes per image times your stack of images. You'll very quickly hit a memory limit if your neighborhood size is large. And there are optimizations built into reduced neighborhood to make it run faster. So if you're using reduced neighborhood, definitely use the optimizations. There's more. If you're trying to compute a distance, use fast distance transform. That returns things in pixels. Usually people don't want their answer in pixels. They want it in meters. Like buffer this image by 100 meters. The way you do that is you run fast distance transform, you throw away everything bigger than 100, and then, run fast distance transform, divide by the square root of pixel area, and that will turn each pixel into a unit of meters, and then you can just chop anything bigger than 100, and that's your mask for buffering. Yeah.
Yeah, quick question about reducing neighborhood. If after I sample only 1 pixel, it will not compute for all area, it will just still compute only for the neighborhood
Correct. If you're sampling a pixel out of a reduced neighborhood, we still need to load in all the tiles for that pixel's neighborhood.
But the computation is only done for the given pixel. Okay,
correct.
Perfect.
As you get bigger and bigger scripts with bigger and bigger geometries, lots of places for things to go bad. When you get a geometry out of something like an image, specify an error margin. The default, I think, is 1 meter. If you don't need an accuracy of 1 meter, use 100 meters or a kilometer. Often this will be the tipping point between too much memory and not too much memory. Simplify your geometries if possible. In fact, if you can, throw them away. Like if you've got 1 million training points and you're just trying to get the bounding box of those 1 million training points, it's often much simpler to just draw a box around your points than it is to try to work through 1 million geometries, consuming a bunch of memory along the way. You can see them, draw a box, and be done if you don't need precision. If you need precision for something, that's a whole different story. But sometimes it's just easier to do it for the computer rather than having the computer try and get a precise answer that you're then just going to buffer by 20 kilometers because you don't really need precision. Anytime you can, throw away the geometries completely. You can use reduce to vectors and never have it produce a geometry. You just want to reduce inside of a bunch of regions. The regions are defined, as the way reduce to vectors defines them, and you don't care about the geometry. So don't have it generate these super complex regional geometries. Throw them away and just keep the reduced results. A few more things that might make your life easier. If you're trying to sample a really complex image, like a CCDC image or something like that, dump it to file first, compute the image, send it to asset, and then sample it. The image export happens 100 times faster than table exports, and the parallelism helps. So you can often compute the whole image, write it to disk, load it back in, and then run a sampling on top of it much faster than just running the sampling and every pixel trying to compute it. Talked a little bit about classifiers and how they can get too big, either by training or by the classifier themselves being too big. When you hit the computed value too large, that's what's going on. And finally, often you'll want a random seed in your program. Never, ever use the JavaScript math random function, because every time you use it, you get a different answer, but that means every time you use Earth Engine, you get a completely unreproducible answer, and you can't use anything that we would cache for you. So you run your script with a seed produced by math.random for your random forest. Great. You run it again. The classifier we just built for you a minute ago is not going to work anymore. We'll make a new one. And so it'll take another 5 minutes. And every time you run the script, it's going to take 5 minutes. Whereas if you were using a fixed seed, it'd take 5 minutes the first time, and then every time after that, it's instant. So this breaks determinism on the system. It breaks how we expect the system to work, breaks all caching. Don't do this. Use I usually say use a literal, like use 3 as your seed or something like that. Often you'll want to use maybe 10 or 20 different seeds, collect them first, make a list of 20 seeds, and then use them, because all 20 results will get cached, and then it will still run fast. Okay? All right, a little bit about our performance tools. Right, so the whole point here was, if you brought me a script, these are the things I'm looking through. So when your script is broken, these are the things you should be looking through. I know I didn't say what exactly to do if you need to reproject and it fails, but I don't know either. I'm going to go figure out what your script is doing and was that really a thing that you needed to do. And so, yeah, that's the best I can do. Oops, other way. All right, so maybe you have seen it, maybe you haven't. We have a profiler built into the system. It kind of works. It's not awesome. It does a little bit. When you run a script with the profiler turned on, we will try to tell you how much memory and how many times and how long each piece took. But we're hampered by the fact that the Java just-in-time compiler will actually squish together a bunch of stuff, and we won't be able to do anything about it. So here, for instance, it is saying the clamp algorithm took the most memory and the most time. Not true. What happened is the clamp algorithm is the last algorithm after a long string of things that were collapsible. And so they all got collapsed down and recorded as the last algorithm. So don't always believe that clamp is your problem. It's just all your band math tends to get lumped together into one unit. Hey, reduced neighborhood took a long time. Well, maybe my neighborhood's too big or something like that, right? So it's suggestive. It's not necessarily authoritative. Okay. All right. So finally, when you need help, this is in the debugging guide. I'm going to reiterate all these items because if you haven't done these things, it's going to be hard for us to help you. So do them. Posting posting a question to our users forum or to Stack Exchange, which we monitor as well. Make sure that you've got a clear title. If you just say I've got a problem, people ignore you. Okay? Try to explain what you're trying to do, not just my reduced region failed. Why are you doing the reduced region? What's your bigger target? Because often it's the case that you're using the wrong tool for what you're actually trying to do. But if we don't know what you're trying to do, we can't say you're using the wrong tool, right? I want to run reduced regions on this 5 million element collection. Why? And then it helps explain. It helps us figure out what to do. Try to cut your code down to as little code as possible that still causes the problem. Because the first thing I do when I get your code is cut it down to the smallest part possible that still causes the problem. You will probably be able to know better than I will what's important in that script. So if you take out a big block of code and the error still occurs, great. That's a whole big block of code no one had to look through. Try to get it down to the smallest reproducible example. And therefore remove a bunch of irrelevant code if you didn't need it. If you've got a big giant 500 line function that you're not using but it's commented out, I still have to get through that, right? It's still in the way of doing all this other stuff. So clean up your code, remove that big function that you're not using so that it's very easy to see what your problem is. Very important, add a script link because if I can't rerun your code, I'm just going to ignore you and everyone else on the developers list as well. So get a link, not the script path, get a link to the script, include the link to the script, then I can run it and see what you were seeing. And very important, about half of the traffic on the users forum is someone saying, I've got a problem, here's my link. And then someone says, can't see your assets, can't run your script. So make sure your assets are shared when you post your link. Okay, this is all in the user's guide as well in case you forget, but you won't forget. Right? Okay, that's my last slide. I will answer any questions you've got, and if you happen to have a crazy script that you want debugged in 4.5 minutes, we can try it.
I have a question. Is it possible to print the file and the line of my print? Like in C, I can do like, underscore, underscore, lines, underscore, underscore, and same with file. Do we have something similar?
No.
No, okay.
Not a terrible feature request. That's actually kind of cool. In general, it's very, so the answer is no. But I'll explain a little bit more. It's often very difficult to tie an error to a specific line in your code because if you're doing something 5 times, those all get squished into one copy in the computational description. And so there are 5 places this piece of your graph exists. I can't tie that back to a single line of code anymore. So we try hard to tell you, oh, there's a problem on line 67, but often it's just not possible because the context has been lost in the process of simplifying your graph. So.
Here, just in the case of a print. Huh?
Yep, no, I agree. Double line would be cool and easy to do. You're correct. Yep.
I have a script for you to.
How about we answer any questions first? What are you getting an error?
Yes.
What's the error?
So it says so it's a really long error. In the end, it says server responded with error code 400.
That's just timeout. Yeah. So that's an important thing. Sometimes you'll get an invalid JSON error or a 400 error. What's happened is we have killed the task, we've killed the query, and the response is mangled. It's not a valid response. And so that just means a timeout 99% of the time. Or you lost your network connection, but that appears to be the same thing. So run it again, and we'll see what happens.
Can I please have one question? So it's, is there anyone who can go first?
Oh yeah, I just wanted to ask about the aside print.
Uh-huh.
Do you have an example handy, or like can you describe some more about that? I wanted to
had an
kind of see that again.
example on that slide. There we go. So just, you've got some computed object, you want to print it, dot aside with a print. Or any other function. It works for map add layer, it works for any function at all. You can add additional arguments, and it will, so the way this really works is aside gets your image, or whatever it is you've got here, and a function, and it reverses them, and it applies your function to that object, and then sticks any other additional arguments in as additional arguments. So you can do map add layer with a visualization parameter here, and it'll work just fine. Any other questions? I'll
Yeah.
debug that in a minute.
Yeah. Okay.
Hang on, let's do one in the back.
Here, what will the aside do? Will it print the mean as many times as it is within the collection? How does I mean, I have to try it myself.
So this is only going to work in the case where you've done this, where you're passing a single element into this function. It won't work when it's mapped because it's print, and you can't print during a map. But what it will do when you call it this way, the first element comes in, the reduce region and the get happens on it. Print calls get info for you automatically, but in a way that's not going to crash your browser. The aside gets this thing, whatever this get is going to be, prints it and returns it. And so it goes back into the mean variable over there.
So if you still map it or something, you won't get like a.
Correct. It'll say you can't use a print.
Okay, nice. That's really cool.
Yep. Yep.
Very, very simple question. I know that you can find the first and the last element of a collection with the first and last.
Mm-hmm.
Can I find the fifth? Print the fifth, for example.
Yes, sort of. This is a place where toList is the right answer. So the toList function, nope, none of those. Okay, so you can't random access into a collection. It's not possible. They are always next, 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 next. What you can do is convert part of it into a list and then random access into the list. So if you want the fifth element, you just convert you call toList with a limit of 5, and it will create the first 5 elements, and then you can get the last one. If you want the 5 millionth element, that's a lot harder. That's a lot harder. It's a reducer, right? Yeah, so it's a reducer. First is a reducer as well. It just happens to be a function that we've copied over. First and last are both reducers. There is a last reducer. That's how you do it. All right. We're over time. Thanks for coming. Good luck.